Chris, Dr. Peter Antonio, Donato Masci, and PK Pendy. A round of applause, please. So, in the morning's initial presentation, Dr. Peter Antonio was kind of cut off because we started beforehand the Q&A answers, question and answers period. So we are going to give him some time just to finish their presentation properly now. Thanks.
Thank you. Good to see you all again. I think our basic message is that the people that we put together in our company have over 40 years of experience in designing every imaginable type of space. PK has a lot of business experience, and I let him tell you about his background a little bit. And what our message is, basically, after 40 years, we have, in our view, finally developed software that enables you to design your space before it's built, to have the confidence that you can design this space and not have to deal with the problems that building it incorrectly may have introduced. And we can do that in very complex spaces, and in very complex spaces that are not just simply rectangular rooms. We can do that with our Nero and Tora software. That is a design service that we offer to the design team. It's an optimization service. And then before I go into that, let me have PK give you his background to give you some idea of the talent that we've brought into this group.
My background is from the AV space. So I started in 1995 at Guitar Center, and then in 99 I founded GC Pro, which is a business-to-business service that we offered. And we did that for 20 years and built it to about 100 million subunit of Guitar Center, which is a $2 billion company. And throughout my career there, and still to this day, because I still am an integrator, and I have a company, Avian Systems, that does all this, you go into lots of different rooms, and you're selling studio monitors, speakers, things like this, and the room, you're always fighting the room, no matter what. The speakers will never win, and your client is disappointed with the speakers. It's not the speaker's fault. You need to invest in your room first, and then any speaker will sound great in there. So having a passion for acoustics and knowing Peter for a couple of decades, and John Storick for 4 decades, we now have a way to predictively design your room so you can listen to any speaker that you want. So it's just that passion to really have a great room.
To reinforce what PK just said, we have those optimization tools, but now we have a user-based tool. ROX is the room optimizer for keyboard spaces, which you can go in. It's an app. It's on our website. PK's making it available internationally. And then we have the acoustical treatment calculator, where you can actually calculate the acoustical products. If you want to buy acoustical products, you can do that. And of course, you know, have 40 years of innovating acoustical products at RPG. George has a lot of experience over his 10 years in creating a nice library of acoustical products. But the idea of the ROX is to you put your length, width, and height in, and Arthur is going to give a demonstration. The reason we didn't go into the demonstration during the presentation is that it's kind of a complicated, demonstration, where you put in all your known quantities, your length, width, and the height, the speaker height, and then you indicate which you can vary. Like if your ceiling height is fixed, then you can't. That's not a variable. And you choose from a library of, I don't know, maybe 100 speakers, which speaker you're going to use in the room. And you can actually audition the speaker in your room before you buy the speaker. Okay? And so that's kind of a summary where we've given end users these tools as an online app. And then we have this more complicated optimization service for more complicated spaces. And, you know, having worked with WSDG for 40 years, we've been involved in almost every one of their projects. So there's just a large body of experience that we've brought into Ready Acoustics. And then we have, to keep the ball rolling, we have 4 very talented programmers and acoustical engineers to keep it current, to evaluate the importance of AI. You know, we are still coding all of our software, primarily in Python, but we can use AI as a guidance. We can use it to, we have this particular issue, so AI is good at proposing a software solution. But then you have to integrate it into your software. The beauty of our software is that we deal with every aspect of the experience, the room, the positions of the speakers, the positions of the listeners, and the positions of the acoustical treatment. You know, Bruno had a nice description of where you place your low frequency absorbers, where you place your porous absorbers. You want to place your porous absorbers at high particle velocity. You want to place your low frequency absorbers at high pressures. The most ideal position for a low frequency absorber is in the trihedral corner, because every mode in the room is located there. The second ideal solution is the dihedral corner, the 2 wall interfaces, you know, and so you don't want to, you may not have the opportunity to address those spaces. That's the beauty of the predictive software. You might only have the ability to put a low frequency absorber on a wall at a certain location. Well, the software will tell you how effective that could be. It's not going to be as effective as placing it in a trihedral or dihedral corner. So if the other gentlemen don't have anything else to contribute,
Thank you, sir.
we can take
Thank
questions.
you very much. Yes.
Yeah.
Well, we've prepared a QR code, so if you want to, you can scan this QR code and submit your questions, and we'll be happy to address them in the order they come. So you can start. Maybe I will start with a question of my own before we have. Oh, do we have? Oh. We have an anonymous question. What's the future for active bass traps? So who wants to take this one?
I mean, they're a tool. It's just like there's a lot of tools to use. An active bass trap is a device that determines wherever its location is. It'll determine like what problem in that, what is the frequency in that particular area that can be treated. And that's okay as a retrofit. We are dealing with solving the problem from the beginning, okay? And so there's a place for that, just like there's a place for all of the acoustical treatments.
You have to know where to put the active bass trap.
And you have to know
That's
where to put
most important. The second question we can
Yeah.
answer. When you say you can hear your speakers in the room before you buy it, does that include high-end audio products as Tidal loudspeakers or Magico, Wilson, etc.? Absolutely. We just completed Tom Martin's room for the Absolute Sound, his room in Texas, and he has Magicos, and we've done a couple other rooms with Magico and with Wilson speakers specifically. So yes, we have those models. If they're not in our library, we will model them and put them there.
So
Yeah, I mean, so we've dealt with the leaders in recording studios, certainly. We've dealt with the highest of end studios. And with Tom Martin, who's the editor of Audiophile magazine, we've dealt with audiophile rooms. We've dealt with home theater rooms. So,
yeah. So this is a general question as well. So which, and this is being asked by someone in the audience as well, which emerging technologies do you think will be most disruptive in terms of acoustic engineering over the next decade? What's your bet?
you guys
I
want
will try.
to?
Of course, knowing the future is not easy, but I believe that using the AI or this kind of machine learning can be very, very useful in order to calibrate the models. Because, of course, we have the technology to do simulation of low frequency in small rooms, or maybe ray tracing for bigger rooms. I will talk in the next in my talk later. But the focus, in my opinion, is as Antonio says, is knowing the impedance to tune the model for the small rooms, and know the absorption, for example, in very complex environments, like such as cathedral, for example, for larger rooms. In order to do this, we have to find a way to match with some measurement, for example, to understand this kind of physical values, physical parameters, and put in our equation, in our solvers. And that's where the AI can help a lot, in my opinion, for the future. So that could be the Saint Grail of the future of the acoustic, in my opinion. Because we have the tools, but we cannot use so well because we need the parameters to put on to the values. And AI can help us.
Christopher, would you say that in terms of speech intelligibility, this would be like if you had your own R&D team for the audio, for sound, just for sound purposes, would you go for that?
Yeah, and the reason why is this thing? Oh, there it goes. The reason why speech intelligibility is such an important key, obviously, because it's tied back to how AI is going to read. The feature set of AI, how it's proposed to the corporate user, is that it's all about translation, and it's all about translation services, and it needs to hear the differences in how a person speaks. It also is doing transcription. So to have a meeting, to rely on a meeting and its AI to transcribe everything is super, super important. And to be honest with you, I would say half of the people that are currently possibly even investigating that Copilot integration into their Outlooks and Outlook teams are looking for that assistant, which is now listening to them, talking to them. It needs to identify them, and it needs to understand that, you know, I'm from New Jersey, I hold back my accent. Somebody from, you know, a Southie from Boston has a very thick accent. You go south to the US, you know, even within Portugal, we were discussing this yesterday, within Portugal, there's different stocks within how they speak. Some people speak 100 miles an hour. That all has to be processed, and that also all has to come very clear into the microphones. So to me, it's not just the power of the microphone and the ability to say, yes, there's a microphone close to my mouth, but trapping all that sound and keeping that away and out, because there's a lot of magic out there. There's a lot of things that companies are doing that, or they'll call it like misting, where they can block out sound behind you, but just keep the sound in front using some sort of beamforming microphones and stuff like that. That's their special sauce. How they do that, that's their business. But that kind of stuff is what's coming to us now. So that to me just seems to be a constant emerging stuff. The video stuff, cameras are cameras, chipsets are chipsets. Every chip is getting bigger, faster, stronger, faster. Glass is getting better. Audio is the one that I think is the bigger key. So.
Great.
To add to that, if I may, the most important thing with respect to speech intelligibility is the acoustics of the space. Speech intelligibility goes totally downhill when the reverberation time is too large. Speech intelligibility goes downhill when you have interfering reflections in the room causing cone filtering. So, as PK mentioned, people have relied on, they'll come and say, well, my speakers aren't doing the job. That's not the solution. You know, the speakers that are designed today are so incredibly good at reproducing sound. It's what they're doing in the room. Where do you place them? Where do you sit to hear it? It's all about the interaction between the sound and the room.
Yeah. We have a question from Bruno Frazenda, actually, who has posted this question for Reddy. Have you considered incorporating the behavior of active bass control systems like PSI or Trenov in your predictions?
Well, we did a room that Tom Martin had a couple of PSIs, and they weren't working. The results were so much better when you designed the specific treatment to deal with whatever he was room. He's just guessing with that, and guessing and measuring. Putting in measuring and lots of putting a responsibility on the client there to really tune their own room. And Trinov is, we sell Trinov as an active DSP solution that goes at the very end of your chain before it hits your power amplifier or hits the speaker. And that's just a DSP like any other DSP. But we don't really take that into account when we're doing any of our predictions. But we do know from our work is that you will need less from the Trinov or any other DSP when you're doing your final adjustments and tuning on the room to your taste, because that's what it's designed for.
First of all, hello, Bruno. I wish you were here.
He is, yeah.
And I remember back when I was working with Trevor Cox, when these active treatments were being developed in corners, and you couldn't get enough power to control the mode, and so they've come a long way, but they're a tool. And when we finish our design, our goal is to make the room neutral. In other words, we want to erase the acoustical signature of the room. But then, after we do that, our clients basically go in and then they tune the room. You hear about room tuning. They tune the room to what they want the room to sound like. That's not our responsibility as an acoustical consultant. Our room is to make the room go away. And then they have their own impression of what the room should sound like. That's after we're finished. We're giving them a clean slate for them to paint whatever picture they want to paint. So active acoustics is just another tool, but it's a tool to fix a problem that doesn't need to have to be there.
But do you think there will ever come a time where active solutions in a standalone will be able to fix or to bypass design or
Never.
passive? Okay.
Never, because active solutions are intended to solve the problem at one place
Yeah.
in the room. You move your head 1 foot and you have a different response.
Yeah.
So our goal is to create a uniform listening environment. And an active treatment is no better than a passive treatment. At least that's our opinion.
Okay. Donato, do you want to take standards also about this neutrality and the approach with Dolby?
Okay. You ask me in their intervention. They talk about neutrality for the frequency response in rooms. Yeah. Or not. I believe that our work as acoustician for studios is 50% science, 50% art. And so, of course, from what I can say is that I like flat frequency response for rooms. But I know that a lot of clients prefer a different kind of frequency response, in particular for low frequency. And I have to tell a story. When we became Dolby Certified Service Partner in 2021, because the Dolby Music Program, Dolby Atmos Music Program starts, we just design a lot of studios for home entertainment and for theatrical, but it was the time where the Dolby Atmos came to the music industry. Everything this question was really tricky, because Dolby asked us to do final calibration for the rooms and to calibrate using a mask, using a tolerance on the low frequency and the mid-high frequency. And the curve is not flat, because Dolby came from the X curve from the cinema industry. And that's a fact, because that's the curve that is an ISO standard that you can better match a far field listening of a speaker behind a screen. And so this is a fact. But when you move in a room without a screen, with a speaker at 1.5 meters, it's totally different. So I can say that this thing would be start in the USA. When came in Europe, a lot of sound engineers from UK didn't want to adapt to this fact and want a flat response in the mid-high frequency. are okay with the low frequency, a little boost in the low frequency, but they don't tolerate a knee in the frequency response in the mid-high. So Dolby told us to be more, it's something that we have to choose with the client at the end. And so in general, when we do Dolby calibration at the end, we can do different setup also to match in different ways. From what I can see, the people that works in EDM or electronic music want a little bit boost on the low frequency and maybe a smooth decay on the mid-high frequency. But if you talk to classical musicians or jazz or something, they prefer flat responses. Yeah. So
we see that. We've done a lot of Dolby rooms.
Yeah.
We do the whole Dolby Dart array system. We also use, even for non-Dolby, we use a subwoofer array.
Yeah.
That we put in the ceilings and some other locations to equalize the pressure. And we've also found that in Dolby creation rooms, like the studios, they're the ones who want a more flat response because they're in the creation and it has to be played back in whatever cinema, headphones, wherever it may be. And in the theaters, the home theaters, commercial theaters, they want the extra.
Yeah, exactly.
They want the low frequency effects to really pop through.
I mean, that is the big difference. If you're in a room where you are creating the musical content, right, you want to know what you're hearing. It's not a preference at that point, because if you tailor the room to your preference, and I'm not saying don't do that, but when you take that mix out of the room, you're hearing something totally different.
Yeah.
You know, Dolby's background is making it feel good, right? That's why a home theater, you're not too concerned about the acoustic aspect of it. You just want to feel good. And so you have a nice surround sound. But in the creation process, it's a very different situation. And it's really hard to get that point across. You really have to be in a room that is not contributing to what you're hearing.
Yeah. And going back to the DSP, in the creation rooms, they can have a preset set for that.
Exactly.
For the playback vibe, you know. Right.
You can listen to it flat, and then you could listen to it with whatever emphasis you want to put on it.
Yeah.
Okay, so moving on to another question. The problem of many modern rooms having lots of glass. And what solutions or tricks to solve this problem and the challenges that come with glass walls
Peter invented something.
would you advise?
So many
Not breaking the glass, except, yeah.
So many years ago, glass is a major problem. And I remember talking with John Sturek a while ago about, because in control rooms, you often have glass walls. And so what we did was to do a micro-perforated foil. It's a very thin mylar foil with micro-perforations. And it's very absorptive. When you have a cavity behind it, you could use a double layer foil for broader band absorption. And then we also created a perforated acrylic panel in which you can get both absorption from the panel, depending upon your air cavity, to determine how low in frequency you can go. Yeah.
So, could you place that question over? Oh, if you want a microphone, we can hand you a microphone.
So to control glass, you have two options. You can angle the panel to control the direction that the reflection is coming, but you have to realize that the only thing that you could control in the frequency of that reflection depends upon the size. Once your wavelength gets to be comparable to the size of the wall, then you're getting a diffuse sound coming back. So just by tilting a panel, you have to realize that you're not controlling all of the frequencies. You're only controlling the frequencies that are specular with respect to that surface that you're reflecting. And then you can introduce perforations to provide absorption. So you have reflection control plus absorption.
What about metamaterials? Would that be able to help?
Metamaterials, I worked on metamaterials for about 4 or 5 years, and the metamaterials have an application, as it was very well described. when you see a lot of the applications, they're above 125 hertz. Once you get down to low frequencies, it's kind of difficult to control that with metamaterials. I have tried, believe me. The theory is there, but when you go to make the panels, they're very difficult to manufacture because the porosity is, the diameter is very, very small. And I think they have a future, but it's going to take a lot more developmental time.
Any material with you consider has some potential?
Any new material?
Yeah.
Not really. I say the newest material is microperforations. We introduced microperforations to a company in Switzerland many years ago, Top Acoustics. And now microperforated materials are essentially becoming the favored architectural solution because you don't see the acoustics. It's a panel. It looks like every other panel in the room, but the microperforations provide the absorption that is required. And we make all kinds of microperforated panels, all forms of perforated panels. Some of our low-frequency absorbers, like for the mid-frequencies, are perforated panels, Helmholtz panels. And when you get down to lower frequencies, we decided to go into these membrane approaches that Bruno described very, very well. And so in terms of new materials, the microperforated foil and acrylic, the membranes, the tunable low-frequency membranes, we go down to like 37 hertz. Those are kind of the new materials that are affecting architectural acoustics.
Okay. We have a question from Professor Rui Calejo to Peter D'Antonio. Do you want to read that one? Why do you use finite elements modeling only until 200 hertz and not in all frequencies? Ray tracing and ISM give better results.
Schroeder frequency.
Yeah, so there's a frequency in. If you look at the frequency response of a room, you have the pressure zone, and then you have the first mode, and then. So the modes are individually spaced, and the problem with modes, not so much that they're a problem, it's just that they're spaced in time, so you hear them, they're audible. And then as you get to a certain frequency, thanks to Manfred Schroeder, who's invented everything else in our field, you get to the Schroeder frequency or the transition frequency to the point where the modes are no longer spaced in time, they almost superimpose on each other. And so as you get above the Schroeder frequency, you get more of a modal uniform distribution. Yes? Yeah.
Yeah, sure.
Yeah.
Please use the microphone, yeah.
Hello, hi. So one of the issues with this method is that it depends on the mesh, because for higher frequencies you have shorter wavelengths, and then you have to have a mesh that is a lot finer.
Do you want to join us on stage?
No, I think it's okay.
Because of feedback, yeah.
Of course. Let me get here.
Well, speaking, yeah.
So the mesh has to be a lot more finer, so you have a lot more points for the computer to compute. And it gets to a point where simply the computer cannot compute anymore because it doesn't have enough RAM, and it would take so long that would become unfeasible to many applications. So this is one of the main issues with high frequencies, with those methods. It's just virtually impossible to compute them with normal computers in a time that is accessible for most applications.
Yeah, quantum computers will make a change. Yeah.
Hope so, yeah.
Yeah, now that is really a new thing, right? The reason we can do what we're doing, the reason we can look at thousands of possibilities is because of computational power.
Yep.
And to use the cloud.
Yeah.
So between the cloud resources and the software that we have, that has become almost another acoustical tool. I mean, it's a very powerful tool that allows us to do all the predictions beforehand.
Yeah. Okay. So, do you want to, please? Oh, yeah.
Hi, I'm Morten from Tonax in Denmark, and I'll just say a little bit more about the glass.
Oh, yeah.
We have invented the acoustic glass now. You can use your normal glass, put it together in a new way.
Okay.
And together with the acoustic from Artnovion, you can make a good room. Yeah. So it is actually possible now to make as bad as glass is, as good as you can make it now. but it's new. I can present it afterward if anyone want to know. But it's a basic that you need a good speechability, and that's what we need of the acoustic material. Everyone. And another, if I can, we are coming from a department of people that are bad hearing. What we don't acknowledge is that we are close to 20% of the population in the workspace. They actually have hearing problem. So 20% of the population we can help with the acoustic.
Yes.
And that's very important.
It's a very good point.
Yeah. And yeah, statement.
Thank you. Thank you. Thank you. Chris, would you have anything to add on this topic? Because is this something that like big companies are looking at in terms of hearing impairment and?
Yeah, last I checked, our hearing doesn't get better with age. No. So it's obviously an issue. Yes, assisted listening is another, I guess, another vertical within AV that is super important at this time. You got companies that are basically, that's all they do is assist into that. To help people with assisted listening, which at one point was just relegated to special events and auditoriums. You're now seeing that in other type of spaces. So yeah, it's a growing field. It's a concern. There is obviously there's a need for that, and then people are being more concise about that. As you walk into spaces, do you need that? And some are going into just regular Bluetooth type stuff with the hearing impairment, and it's helping. But yes, that is definitely on target. But as far as class goes, man, I still have a lot of bad memories from that one room. I think I wake up in cold sweats thinking, okay, thank you, appreciate it.
And there are methods to determine speech intelligibility. We've worked on that for ages. And so, you wonder, you go into a train station, why can't you understand what stop to get off? You go into so many areas, and the acoustical aspect is what determines the speech intelligibility, as long as the auditory hearing.
But can you fix a drive-through speaker thing? I can't understand that.
Well, that's where we have the integration.
That's where we end. All right.
Okay, when we're heading for our final minutes, we're just changing the topic for the problem of architects not knowing or not being willing to incorporate acoustic technologies or solutions. So what's your advice on how to deal with that? Yeah.
We deal with them every day. Almost every one of our projects has an architect or an acoustical architect involved. And it's just having meetings with them and having them incorporate the treatments into their design. I think it's just spending time with them.
Yeah, from an integration standpoint, that's the architect will design the space. An acoustician will come in and design the audio for the spaces. Then the end user moves in and everything changes. Yeah. That's the hardest part, and that's the part that we can't control on our end. Technology doesn't solve everything. We do a lot of cool stuff. We add wow factor to a lot of cool things. But the fact is that until when all the trades leave and we're left behind like I was for 13 years, then that's where the ask happens. And that really starts not with the architect, but in the design plan of that building, there needs to be more end user questions asked. What is your intent? What is your purpose? Because a video conference room is not a presentation room. It's not a huddle room. And there's 1,000 different names for whatever room you want to create. And you can create a 3-person conference room that it was intended with no technology. And that could be glass. But, what happens when they bring something in there? And then unfortunately, because of where we sit on the food chain, and that's commercial audio video, we quickly get that term called value engineering thrown at us. And for many years early on, when I was in my career, audio conferencing systems were eliminated in place of a Starfish phone in the front of the room. And that worked. It was, I hate to say it, but it was good enough. It's now needs to be integrated into the whole space, into the room. And I think that's where there is a mindset that needs to change. And going back to the architect and stuff, the architect and the acousticians are there day one, that's awesome. But when they leave, then it turns into the Wild West, and that's where the on-site engineer really needs to, or the on-site people that are left behind that work for the companies have to be better trained, better adapt to asking the questions ahead of time and meeting with these folks early on in the process, because that's the biggest fault that AV has, is where we fall into the process. And we're usually the last ones coming in. That's where usually the last trade to leave, unfortunately.
I mean, that's the issue. Design is a compromise. We talk about it in terms of the 3 A's. You have the architecture. You have to know what is accessible architecturally. You have the acoustics. What is accessible acoustically? Where can you place things? And then you have the aesthetics. What does the room have to look like? That's why I spent so much of my career designing products that are not visibly acoustic. You know, an architect doesn't want to see an acoustical product. He wants to design the acoustical product. That's why we developed this software where you can put in the topology that the architect wants to see. The acoustician can look at the results from our calculation, and he has information to go back to the architect and say, I know you want to see this surface, but and we'll try to do it, but you have to realize that we're not going to meet our objective if we utilize that surface. So it's a compromise.
Mm-hmm.
Okay, so I think we have time for one only last question, and we have a suggestion here for each speaker to point out the technological advancement or problem to be solved that you are most excited for witnessing in the next 12 to 24 months. And we would finish with this longing.
Mine's not going to be audio. Audio's easy. Mine is going to be more on the transport and standardization. In the world of AV, standards is a hard thing for us to get our heads around. And I'm currently watching a war brewing amongst how signal is transporting. And the reason why I say that is because 2 weeks ago I was in Amsterdam at IBC, and IBC is a broadcast focus show. And then I go to an AV focus show, and when I hear the miles apart they are as far as transporting video and audio and everything, we're trying to cram a lot of stuff into a pipe, right? It's the 10-pound turkey in a 5-pound bag, and we're trying to get it down from A to B in one piece. And then the two worlds that I play in, which is the broadcast side and the audiovisual side. The broadcast side wants uncompressed raw sent to one side. AV wants to compress it and send it most efficiently because they're sharing a network. That will be an internal battle for the next 18 to 24 months, is how we're sharing it. Now, everybody can go in and talk about VPNs, and I can go down an IT conversation that I don't want to have. But it's an interesting one in that there are different standards and different groups within that and how they send that transport. That's obviously, for me, it's important to watch because I see a connection between broadcast and IT and AV all starting to come, and it's becoming more apparent now than it was 3 years ago when I went to my first NAB. And watching this kind of go, you're listening to AV integration companies start to talk about Adobe and Edit, Share, and processing and how editing, and it's very different. They're just not talking about audio, video, lighting, and control, which was our basis foundation for many years. So there's something new coming, and that's my feeling.
Okay, Donato.
I don't know, in the acoustic field, of course, the audio industry is faster than than the acoustic, probably. I totally agree with Antonio about the micro-perforated foil, and I think that it can be used not only in indoor acoustics, but also outdoor. For example, let's think about using porous material for barriers in highways, they get wet, and we can use, in this case, microperforated steel in order to make it more efficient and longer than the others. Exactly. And of course, about the active absorption, we had an experience in the past. I can see that active absorption can be something interesting, but at the end, it can be used like the passive one. So in general, the price is very high. Yeah. So if you have to balance this now, it's not so effective in my opinion, but it works quite well in the very low frequencies. And now, if the idea is, okay, using active absorption on the very low and maybe porous material, the crossover frequency is not enough now because it lacks between 100 to 200 hertz and is a very important part of the spectrum. Yeah. So, okay. I don't know.
Metamaterials. I actually want to see one in real life that works, that we can use. Okay. That's all I want. We've been studying it. I'd love to see something come to fruition that we can use for many different applications.
Okay.
Very simply, more computing power. We know how to program. We know what we're doing. We just need more computing power.
We need a meeting with NVIDIA.
Okay. Okay, so thank you so much for this very, very inspiring moment. A round of applause.